Good evening, everyone. On behalf of Marthandam College of Engineering and Technology, a warm welcome to the resource person, coordinators, and all the participants. We are here for Atal Fdp on emerging trends in space and computing technologies. It's my great pleasure to introduce our resource person for this session, scientist Sri Ramachandran. He is outstanding scientist, former group director, Vikram Sarabhai Space Center, Trivandrum. His native is Madurai, Tamil Nadu. He did his graduation in BSc Applied Science from Tyagarajar College of Engineering, Madurai in 1981-84 and completed BTech in Production Technology from Madras Institute of Technology, Chennai in 1984-87. In 1987, he started his professional journey in Mecon Limited, Ranchi, as an engineer and served there for a period of 1 year and 5 months. In the year 1997, he has completed his MTech in Mechanical Engineering from IIT Madras with gold medal. Later, he joined in Vikram Sarabhai Space Center in December 1988. He has put in nearly more than 3 decades of his life in the design, development, assembly, and flight integration of various sub-assemblies, mechanisms, and pyros for launch vehicles. He has developed a lot of insight in the practical aspects of the system design and configuration. He has been conferred with ISRO Team Awards for the development of 4-meter heat shield and relaunch of GSLV D5. He is a life member of various professional bodies like AESI, SAQR, ISNT, etc. Now, I would like to hand over the session to our esteemed resource person, Sri Ramachandran. Over to you, sir.
Thank you. Thank you for the nice briefing. I welcome you all for this session. First of all, I would like to thank the Marthandam College of Engineering and Technology for identifying me as a resource person in their ongoing faculty development program. I actually specifically thank the coordinators for interfacing with me and making all the arrangements for even helping me with the presentation, putting on the projector. So thanks for this, and I wish all the best for all the participants. So let me start my presentation. So I thought initially you might have seen in the briefing that I gave a title of implementing quality and reliability assurance in aerospace sector, which became too general. So I thought I will use my professional journey in a specific area wherein I have put hands-on experience in launch vehicle mechanical system. So I will be able to walk through the journey and share with you what are the challenges in this, what are the salient aspects of this implementing the quality and reliability assurance in aerospace, which can be generally applied in aerospace of any cadre. If it is aircraft, you can take a glimpse of this and apply that. If it is a defense system also, you can use this. So that sense it is general, but it will be out of my own experience and what I have faced in my experience. Go ahead with the next slide, please. This gives some overview of what is launch vehicle, what are all the specialized areas required for building a launch vehicle, how to configure a vehicle and design it. So it comprises of so many areas. So which will be converted into system engineering and finally a product in the launch vehicle, and finally after passing all the verifications it will go into the integration for this. This journey takes nearly 10 years on paper, arriving at a configuration to meet, say, if you want to have a launch vehicle to put a 10-ton satellite in a GTO. Today, if you work on this with all these experts in a task team, they will give you several configurations of combination of propulsion systems. Finally, slowly we will configure the vehicle with all the brainstorming. It will be becoming a project report which will get uploaded by higher ups, and then they will give a go ahead and form a team to work on this project. That project journey will take nearly 10 years to arrive at first vehicle built in the launch pad. So it's going to be a very long journey. It will use all the elements of past experience. Still, it will try to scale up their levels of propulsion system and control system on all these areas so that higher capability vehicle is realized. So it is quite challenging. Use the past. In this process, they are using two major reviews. One is this ITR, Integrated Technical Review, which will be comprising of national experts with academic persons from renowned institutions and other defense and research centers. They will come and review our progress, give some guidelines. Finally, ITR2, when we are ready to go ahead with realization of hardware, they will do a second review whether all the actions what they gave has been fulfilled. Now the vehicle configuration is verified through, say, internal testing and controllability studies. So many things they will verify, which are all more like a software and model work. Once the model work is put on paper and presented to them, if they give a go ahead, the realization process starts. So this is the journey of a vehicle which involves multidisciplinary science. We can go to next slide. So when you come to mechanical system also, it is not a one system. It is having structures, mechanisms, control, actuation, systems like propulsion, assembly, and integration. All this comprises of very closely tolerance hardwares. And not only that, these structures are very optimally designed. If you ask what is the difference between an aerospace structure and a civil structure, some bridge, for example, it will have a lot of margin. So it need not have to fly and it need not put a object in an orbit. So definitely the mass ratio plays a very crucial role in our every system which is going into the launch vehicle. So it is very carefully, optimally designed structures. The margins will be much less than 1.25, whereas civil margins will cross 10. So that is a comparison. The margins factor will be more than 10 in case of civil structures. In our structures, it will be 1.25. That is a comparison. So it involves all this cleanliness control during certain like control and propulsion systems have to be assembled in a very controlled, contamination-free environment. So all such systems are very elaborate systems, facilities. So it cannot be just like that started. So it requires very expensive build-up of infrastructure. That's what I meant by this. Of course, the manpower is cannot be spared. All these people are very highly skilled technicians. So they will be given specific training also wherever it is called for before inducted into launch campaign. Can we go to next slide? So this is indirectly I told about structures which is very optimally designed. Not only that, it has to work in various environments. Some are in vacuum, some are in high thermo-vacuum, some are in high dynamic environments like vibration, shock. So all such things are also very specific to our space system. If you see a automotive vehicle, that is very reasonably you can understand this environment. Maybe road conditions may be bad. To some extent, road shocks will be there. So shock absorber design and may be challenging to that extent. Here, aerodynamic ascent itself poses all kind of criticalities for all the elements. So that is one unique and no repair chances. I have put limited repair only in case of space station where they can go and repair if they find some problems. The next set of crew go and repair. But in our launch vehicle, there is no chance of repair. And I already told that the weight should be very carefully estimated. The project gives a budget estimate of mass for every components systems. It should not be exceeded. Otherwise, their payload capability will come down. So it is very carefully, but we employ very high strength materials to take care of this. With a minimum weight, we can even go for a maximum performance. As I told, very high cost facilities, dynamic testing like vibration test, thermo vacuum chambers, all these are very hugely expensive. Static test facilities, which are all required to be built to test and evaluate our systems. Regarding materials, they are all sophisticated materials or high strength materials for which we may have to develop our own processes and procedures. So sometimes it may not be available readily, so we may have to put our own standards. Finally, all this, in spite of being maturing materials, they have to meet requirements of high reliability and safety. Next slide. Oh, this is a uniqueness. Actually, you might have seen Chandrayaan launch, which got the global welcome and appreciation for entire ISRO and country. So the heart pounding moment is this: when you sit on the vehicle launch pad during the launch, last 10 minutes is on an automated launch sequence. Nobody can anything. It monitors all the parameters. It gives a lift-off signal. Its vehicle is lifted off. Another 18 minutes of launch vehicle journey also very exciting. Every system has to perform. You might have seen the nominal trajectory and the ongoing trajectory of the vehicle. You can see almost it overlaps. So that way, it is really heart pounding. It is when the vehicle has put the satellite in orbit and the mission launch range director says the mission is completed successfully and the mission director also confirms that it is put in the intended orbit. It gives us some sort of satisfaction like winning the World Cup, nothing less than that. Everybody, if you go in the launch pad area after the launch, the people will be bubbling with energy and jubilation. Everywhere you find happy faces. So this is a thing which you will not be getting in any other industry. This industry gives the challenge, but once the challenge is fulfilled, you get the complete satisfaction and real jubilation. Next slide, please. Next slide. Can you go to next slide, please? Is it audible? Muted. You are muted.
Yes, sir. Yes, sir. You are audible.
Because the slide is not moving, I thought they can go to next slide. Can you go to next slide, please?
Slide is not visible, sir.
Actually, I asked them to go to the next slide. It was stuck there, but from college only, I think they are operating. Can you go to the next slide or any problem in projecting?
Sir, please wait. There is some technical issues are there. The host is solving the issues, sir.
No problem. Go to sixth slide. Six. Yeah, this is all. Show PowerPoint show. Next. Yeah, this is whatever I told, exciting and jubilation of successful launch. Exactly opposite is true if the launch vehicle is failing at the launch. It breaks all our moods will go. And there is a reservation on future of that particular project. It halts the whole progress of the project for at least 6 months to 1 year. Anyway, loss of efforts and money and honor, all this will bring the mood of the people down. Bringing back again to a normalcy takes time. So that is a one risk. If it is failing, it will break your heart, it halt your progress. You have to redesign some elements, then it will go back to some levels of progress, whatever already made, then you have to come back. So, anyway, ISRO is capable of coming back, so that is not a big problem. But temporarily, everyone will be down. What went wrong? They will be curious. There will be a national-wide committee which will address all these mishaps and they will give suitable remedial measures. We will come back, but this will halt the particular project sometime. And sometimes if the common modules are there in any other launches, other launch vehicle also will suffer some progress halted for some time. After verification only it will be allowed to go ahead. So in that sense, it is highly risky. Space will not forgive any mistakes. So that has to be kept in every time when we do a space system realization. this aspect of space, it will be unforgiving, and the problem, whatever escaped our screening, will show up in flight, and definitely we have to pay the price. Next slide, please. So this is another mishap of Challenger shuttle and Columbia. This is very famous. We lost the very manned mission failure, which is ultimate. We have lost all the crew. When we go for manned mission, all these lessons are addressed. So how to have a health monitoring of the vehicle, and how to detect that any problems are not there in the ongoing vehicle. Before return, we have to verify this health of the uh, launch vehicle or which is carrying the crew module. Subsequently, the crew module during orbiting, we have to constantly monitor. If there is a problem during the launch vehicle ascent itself, we should bring back the crew at any cost. Even if we are not able to fulfill the mission, we have to bring back the crew. That is the crew safety. The range safety aspects are there in every launch vehicle. That is, the vehicle is deviating from this intended path and crossing a safety corridor. Then the range operation director, who normally, if you watch a live program, he only says the first stage performance normal, second stage performance. He is the person authorized to monitor this. And finally, he will see that if there is deviating beyond a safety point and vehicle can pose threat to your local landmass, then he will take the call after consulting management to destroy the vehicle on in air. So range safety aspects are there. Every stage is having a distract system mounted, and the command is given based on the requirements. So far, we need not have to do that. Either the failed rockets also were falling in the sea, not posing threat to the landmass, which is a blessing. Next slide, please. This is just to give an idea of the space is realization of space systems. It is through industries, large number of vehicle systems are realized. All have to be channelized to the individual centers and finally reach the launch campaign. So all these have to follow the lane. They cannot rush up. They cannot just do something and surrender this to the project and come back. Similarly, all our modular concepts are there. They have to realize and deliver on time. And between the teams, we have to communicate. There are automation is there in QC. So right from the work center, they can communicate with people. If there is some doubt, they can always check whether what way to progress. And if there are some corrective actions to be done, these communication systems are there. Even every deviation, however small, it has to be analyzed thread back. If possible, it has to be sidelined. Otherwise, it has to be decided based on facts and tests. That is what I have put. Some other slide I will indicate what are the non-conformance protocols. And no change in established process allowed. So no work center or in-house production, it cannot change. If there is a want of certain mission or method or supplies, they have to wait and adhere to the process. No ad hoc way of doing things. So that has to be checked with the design and development team whether it is okay to go through an alternate route. So that has to be learned before you dig. And this is a philosophy. Every time we have to meet the requirements. Not that once we have done that is not sufficient. Every launch is unique. Every launch vehicle mission is a surprise to us. Even though we have proven so many PSLV flights, every flight will be dealt as a new vehicle. So every time when we do this launch operations or realization of launch systems, it should be treated like a new system and we have to do it right. Next slide. Next slide. This gives some idea with quality assurance and QA plan. This is okay. So QA plan will give you the overall responsibilities with quality assurance responsibilities with QA. So they have to define the roles and responsibilities of all the people involved to make the product right from the project to realization phase. Who will do the quality control function? Who will do the process control function? They define this through a document called QA plan. This is done in a planned and systematic manner to ensure that the company's quality objectives are met at every stage of realization. So the QA people or the management representatives, they give the confidence to management that company quality policy is adhered to at every stage of realization. At the same time, to the project who is a customer, they say that the product delivered to the project meets the quality objectives. So this is what is the definition of the quality assurance, and what how they do is through a QA. Next slide, please. So this is what I have already told. This insists on documented procedures, and all the requirements should be put for every phase, right from the development phase to the qualification phase, acceptance phase, and finally the flight delivery phase. Everywhere these documents and procedures are in place, and every quality assurance agency who is involved in every stage gives a paper that until then it is adhered to, compliance is there, and they will give a compliance certificate. This is what is monitored by the overall QA system people. Next. This gives the overall plan, whatever I told right from concept review to the flight realization phase. Here I will try to say two aspects. One I have put as qualification testing, and later I have put testing and acceptance. So here you can just note that the qualification testing will bring out the margins in the system. It is done to evaluate the design margins. So design margins are something I told, the factor of safety of 1.25 is put in a typical structure. So these structures or prototype at realization, it will go through the required load cases and ensure that this is passing that qualification testing, proves that the factor of 1.25 is really there in the design through the model tested. So this is the aspect of qualification testing. Some other aspects of qualification is there which I will cover later. The flight system acceptance is slightly different. This is done to bring out or assure against the flight hardware against a random defects such as workmanship or raw material like that. These defects cannot be captured in a regular screening process. In spite of the screening, it may escape. That is the idea. So it should pass successfully in flight. So these factors are slightly low. So factor of safety for qualification, when I told 1.25, this will be sometimes 1.1 for certain high caliber pressure vessels. It can be as high as 1.5, where the margins will be much higher than 2, or the factors will be much higher than 2. So this is acceptance test is done at a lower level, just above the flight levels, so that once it passes, it will give the confidence that it will successfully pass through the flight regime. That is the idea of acceptance test. We can go next slide. This is what I was telling in non-conformance. However small, we should not allow. In case of some doubts, we have to check with the designers or whatever I told you earlier. But we have a procedure, a local salvage committee, which will address the minor deviation and give a clearance after discussing in the committee and confirming that it is only minor. They clear, because all these products have to be going through a process, and finally the product has to be realized and submitted for flight. So there is a timeline involved. So you cannot wait for whole reviews to complete to get this product lined up for production process. So this local salvage is empowered to give go ahead for based on their assessment as minor deviation. If it is major or catastrophe, they will not clear. Either they can reject or they can refer to the next level of review called non-conformance review board. This is a larger board which will have an experts in all the areas, so they can even address some specific cases of materials, some discolorization in components, which a local salvage is unable to decide whether it is a corrosion or a simple scratch. So such a things which they are not able to decide, they can pass on to NCRB. These products will be sidelined for some time. NCRB will review, and some specific task will be given to experts to go through and give their assessment. If they say it is not a corrosion, it is can be accepted, then they will give a go ahead. So this will come back later in the line of production at a later time, or it can be sidelined if they feel it is corrosion, it cannot be accepted. So, but the local salvage committee decisions also go through a process called ratification by NCRB before going to the flight readiness part. So before submitting to the flight readiness after processing, this will get the both LSE clearance and NCRB ratification. In flight readiness review, they check whether all the non-conformance have been reviewed by LSE as well as NCRB. That is what they verify. This in flight readiness review. All this will be given, data will be given by the quality control and quality assurance agencies. Finally, it will be a certified hardware for flight. We can go ahead. Next slide. Now we will come to the reliability part. Quality assurance is very clear, systematic operations, documented procedures, set of people who take care of every stage of realization. They give a final paper on product and process compliance. And if there are non-conformances, there are specific processes which everyone has to adhere. Once that is over, the QC confirms that in FRR that all these things have happened. So finally, quality assurance concur to that, based on which FRR certifies the product for quality. This is the route for quality assurance. When it comes to reliability, first part is very clear. If you ask anybody the reliability of what is meant by a reliability, it is to perform over time. Last year I purchased a mobile, still now it is okay. It works well, no hang, no green line, so everything is fine like that. You feel this particular model by particular company is reliable, we say. Quality is adherence to specification, but over time, if it is maintained, then it is reliable. It is also can be viewed as a failure mode avoidance. If it is not having any failure mode left with, it has got enough success paths, so no end functioning will be affected. Then it can be considered as a reliable product. But these are all some deterministic approach way of defining. But what we really do is the probabilistic way. You can read the definition. What it says is the probability that an item works successfully over a specified period of time or under intended or stated conditions. So all these words are important. This is a probability, and the system should successfully functioning probability, and it should perform over a specific duration, and then under stated conditions like it can be thermo vacuum environment, it can be dynamic environment. So all these stated environments it should withstand and perform successfully. So all these aspects are very important for reliability. Now let us see some more of this in the subsequent slides. Go ahead, next. This is put in some other fashion, same. The failure time to failure should be beyond the specified intended period of time. So it should meet the designated period of time of functioning under stated conditions. That's what the first para says. There are certain prediction methods available for electronic parts. Mill handbooks give the failure rate. Similarly, for certain machine elements also, failure rates and reliability input data is available. But this is all okay for part selection, but it is get into a system through a process. So that process related, how it interact with the subsequent during the process, it is not come in the prediction. So you can use it for selection of high reliability parts, but that will not give the end reliability of a system through prediction is difficult, or it has got a drawback. So normally in avionics we have the preferred part list, which will be taken care of by this mill and books and things like that. If we have our own established uh, parts, that also will be used. When you come to demonstration, reliability also can be demonstrated through test. It is slightly fishy how you can get a reliability by testing is a question I will explain later. But first is a success rate. You might have seen in 0.99, launch shuttle is 0.999. That is 1 in 1,000 like that. It is nothing but number of successful tries over the total number of tries. That is what meant by success rate. We have another way of expressing this. That is reliability is connected to number of trials, the number of failures and confidence level. This expression I'll explain in subsequent tests. So we can decide if you fix how many allowable failures and what confidence level you want to demonstrate reliability. Then you can arrive at the number of tests required to meet this reliability. Just an example I have given, the classical method. If you want a 999 reliability, 0.999 at a confidence level of 0.95, the test requirements are nearly 3,000. No project can give that large time required to meet this many number of tests. We will address how to come out of this. Next slide, can we go? So now I will introduce one particular area where this demonstration, reliability demonstration is happening. These are all called one-shot devices. This one-shot means it can be operated only once. These are all used for some mission critical function like stage separation, stage ignition, or even the liquid propulsion system allowing the fuel and oxidizer into the chamber. So these are all very important functions for successful functioning of a launch vehicle. Bolt cutter, it cuts a bolt, thereby affecting a separation. Pyro thruster affects a ball lock system, which keeps the stages in locked condition. And upon command, this pyrothruster gives a definite stroke to a ring which releases the ball, thereby affecting a separation. Similarly, a pin pusher also a ball lock system, which is released. The ball is released by activation of this pin pusher. These two are different valves. One is used in liquid engine, one is used in space liquid apogee motors. Go ahead, next slide. So these are all single shot as I told. So these are all the functions as I explained. The first is the broad functioning of these devices, where it is used, which I explained. The second is the unique characteristics. So it cannot be checked prior to flight because of single shot in nature. The item which is getting to flight assembly cannot be tested, which is a huge drawback, but it is employed in a very crucial function. So you can note this. So definitely something we have to do on this to provide confidence. And it is a very, but in spite of that, why we are using is very high energy it will deliver per unit weight. All are the photo itself you might have seen. All are very miniature systems. If you want a mechanical testable system for similar functions, it will become very huge. Definitely, it will eat up the payload effectiveness of a launch vehicle. That is why, in spite of such drawbacks, it is still used. And another drawback is it will deliver the high energy in a very short duration. So high impulsive load and shock loads will be there in adjacent systems. When in vehicle engineering, this has to be kept in mind. No sensitive packages or items should be kept very near to this actuation systems. That has to be done. And some of the things are now overcome. Engineering approaches are available of late, but originally it all made based on hugely some thumb rule and experimentation, trial and error type of systems only available. So they decide on some charge quantity to make it work by trial and error. This was what followed. Now, dynamic even modeling of these devices are available. They can precisely predict how much quantity of charge is required to perform this function with these intended margins. Go ahead with the next slide. This now I will say how to go this reliability estimation through a number of tests, whatever I told. So it is the outcome is success or failure. So go or no go. So naturally, such a probable space, we can go for binomial distribution. So if you want to incorporate certain allowable number of random failures, this is the expression NCI r power n minus I to 1 minus r power I equals 1 minus c. Sigma I to r is the number of failures allowed. But in go no go type of system and critical system, we don't allow any failure. So this expression come to a very minimal r power n equals 1 minus c. Here I will say that, as I told you earlier, 0.95 confidence level, if you are aiming, it will become a phenomenal number. So it is an understanding and judgment that anything around 60% confidence level is good enough. If you have number of tests to meet the reliability of certain numbers. How to arrive at that number, I will come late. So we can arrive at that number for each element. We can arrive at a number of tests for a confidence level of 60.6. So 1 minus zero point 0.6 will become zero point 0.4. So for this R power n equals 1.4. What is the number of tests we can arrive based on that, based on the estimate or the demonstrated reliability required. So the same expression can be used to assess what is a PSLV flight after a successful last flight. You can put the same expression because there also we don't allow any failures. So number of successful flights, if you put, you will get the reliability of PSLV. This is called a reliability growth of a launch vehicle. That also using the same expression. Can you go to next slide? This is another way of estimating the reliability for structures where I was telling the factor of safety is involved. So factor of safety on one hand, which is because of the ratio of strength to stress. So it should be more than 1.25. So that is a mean strength to mean stress is a factor of safety. But both the strength and stress follow a normal distribution. There is a small region where the stress and strength can interfere. So you have to choose a strong material to keep this very low, and stress also will be quantified, and factor is put to keep this stress away from strength. So this is what this distribution of normal distribution also will give based on the coefficient of variation of both stress and strength and the factor of safety involved. We can get a table. That table also will give. Suppose in aerospace structure area, we are using superior materials, so the variation will be less than 5%. If I say 5% coefficient of variation and factor of safety of 1.25, that gives a reliability number of say 0.69, 99. So mostly the stress strength interference probability distribution will lead to this order of reliability. So, provided it is demonstrated through qualification testing that design policy. Go to the next slide. So these two binomial distribution and normal distributions are used to for reliability estimation. Now we will come some aspects of reliability in design. So reliability definitely cannot be tested out or inspected out. So definitely it has to be built in design. As once we told, parts should be of high reliability, materials should be of superior quality, and process should be controlled, and certain aspects like critical thickness and critical dimensions are to be verified for every part to ensure that there are no anomalies. So right from concept stage, the reliability has to be kept in picture, and it should be verified at every stage. Sometimes the design will go through an iteration. Still, there should not be new failure modes and new cause of worry. So every stage, the reliability has to be kept in mind. Robust design is how to control these errors, how make system capable of accommodating certain noise factors. That is about robust design. Factor of safety and derating are one and the same. Sometimes we use it for shelf life. One chemical systems don't have a shelf life. It can be some 3-year life. Beyond 3-year life, also some successfully flown items are available. How to use it? So we will test it to extend this. The 3-year life itself is given based on some 4.5 years of successful testing. So that 4.5 years of data derated to 3 years and applied. That way only shelf life also is specified. So this order type of deratings are there. For further extension also similar procedures are there. And wherever possible, we have to incorporate redundancy for tolerances. Definitely, we will come to where to stop redundancy, how it can lead to some other criticality like complexity and all. We will dwell on one or two slides later. This design improvement by reliability engineer will be evaluated by techniques called FMICA and FTA, failure modes, effects, and criticality analysis. It is a bottom-up approach. Every element in a system, if it fails, what its effects are to the immediate adjacent element in the system. whether it will cause further failure or it is tolerable because of more success paths like that he has to assess. So it is a very exhaustive technique. It covers all the elements of a system. Of course, it is time consuming, and so we have an alternate way of assessing what are the major failures or probabilities we have to take care. That is a fault tree analysis. So, if you want to know how a system will not function, say how a solid motor will not get ignited, we can define this as a top event. What are the probable failure scenarios which will lead to this end effect of this? So that is a it's a combination of and OR gates. Some may be both have to fail in case of a redundant. Some one failure is good enough to cause the failure. So it will be a combination of and OR gates. So FTA will be very useful for certain defined top events. You can assess very quickly. FMECA is required to understand the whole system. And certain failures during the development phase and qualification phase also, we can take lessons when new similar systems are designed. We can take inputs from this. What are the corrective actions we have introduced in one system, whether it is applicable in a new system because of some similar process or materials are used. That sense of failure analysis and feedback also will help. These elements, these areas where QA and reliability engineer can contribute. Can we go to next slide, please? This is indirectly putting the same. The roles of the QA tools employed in various phases of product life cycle. Design phase I have already told. Qualification phase I have told something on qualification margins. Here I have applied to this single shot devices where the qualification test plan is aiming to demonstrate reliability. So here in addition to this functional testing at ground, various environments of these items will be subjected. And every environment, certain elements will be taken out and tested to find out the influence. Suppose thermal soak is the first environment, certain elements will be tested. If it passes, next environment like thermo vacuum will be introduced. After that, there also some elements will be removed and tested. Like that sequential subjection and pull out to assess. Dynamic environments also will be done. Finally, all systems will be tested, whatever remains, which will go through the entire series of environment and whether it has passes or not will be verified. This qualification test plan and its sequence is made by QA. In this case, QA only defines all this number of elements to be subjected, whether it should be tested in a single initiation scheme or a dual redundant scheme during testing, all these things. In margin also it is slightly different. Whatever I told 1.25 factor, here the margin demonstration is suppose certain quantity of charge is designed for the flight, then it should perform under 80% of the charge to successfully function the same. Otherwise, 120% also it should function without causing any disintegrity to the hardware or housing. So both are trying to ensure the both the limits. So that is a margin demonstration I am addressing. There are certain explosive trains which also involve certain interface gaps which dictates its successful functioning. Those gaps are also go through a margin. Similarly, a specified gap is there. So during margin demonstration, more gaps will be done to see what are the limits of this gap. Accordingly, specification will be enforced. So that is also a margin demonstration. In flight acceptance, here slightly different because as I told, the items cannot be tested for flight. So this small quantity from the flight batch will go through the same qualification test sequence and tested. So it is called VOQ, verification of qualification on a flight batch. This is a specialty of the single shot devices. Once that is cleared only, it will be acceptable. The batch will be acceptable for flight. Integration documents are and checklists of the integration phase, which is mainly involving assemblies. Post-flight, all these performances are analyzed During the process of campaign, any anomalies or some difficulties are there, which will be also presented in the post-flight review committees as lessons learned, what are all the improvements to be done in the subsequent flight. Also will be discussed and implemented either in assembly checklists or operational documents or certain improvements in protection or storage or transportation like that. Good. Next slide. So this is putting some other fashion how to improve reliability, some reduce complexity, proven systems, some number of active elements in a given chain, because the reliability in a series chain, if n elements are there, it becomes a product of all these elements. Reliability becomes a system reliability. Naturally, all are less than one, so the product will become lesser. One element's value, if two are in series, it will be lower than one element's reliability. So definitely you have to reduce the number of active elements in a chain. Use high reliability, we got talked design, modeling, redundancy. So these are all salient aspects of improving the reliability in design. You can go to next slide, please. So similarly in FMECA, we will see what are the weak links in a design, what are the single point failure modes which have to be addressed. Either it will be tested out or if possible redundancy and success paths have to be generated. Otherwise, the second point, redundancy. And certain things like critical assembly, there are certain hold down goals, some restraint elements are there in a system to enable ease of assembly and safety of people. These elements will prevent a system from releasing or jettisoning. So such hold down bolts or safety pins have to be removed. Otherwise, system in spite of functioning, it will not separate. So such an important checklist have to be verified whether it is incorporated there. So and it is implemented during campaign, launch campaign. So as I told, it will give a good insight into qualification, whether to do in single chain mode or dual chain mode, like that. Go next slide. So here one example. Go to next slide, please. So what I'm saying is it's a heat shield separation system. It is having both vertical separation and horizontal separation. The heat shield has to be jettisoned. Jettisoned means imparting a sufficient velocity, something like 6 meters per second. The system has to deliver to the fairings so that it clears the vehicle. The vehicle is in ascent mode and payload firing is separated during vehicle is in acceleration mode. So it has to clear the vehicle as quickly as possible so that it will not collide with the ongoing vehicle. So that 6 meters per second is a specification for the vertical separation. Horizontal separation is a bolt cutter and a clamp band rod I have explained. The command is received by the autonomous safe on device. Subsequently, it is taken to the respective initiation point of system through a transfer lines, through a manifold, and these are all explosive units. So if you don't give additional length for a vertical system in comparison to the horizontal system, both sometimes happen simultaneously or sometimes vertical system may slightly precede the horizontal separation. In that case, even though energy is delivered, still it will not be going out of the vehicle. So during this initial design was not having this additional length of the transfer lines in the vertical separation circuit. Subsequently, through this finding, we have incorporated all the launch vehicle is having this additional length of pyro in vertical separation. This is one of the example I thought we can contribute by carefully looking at the design. What kind of scenarios can happen? Go on to the next one. Similarly, some area 4-point redundancy instead of dual redundancy. Some hold and release systems are there, which is hydraulic system. There also we have gone for quadruple redundancy. The quadruple, this larger hold and release system is used in GSLV. This is to prevent vehicle from lifting off. when L40s are firing. So it is verified for a proper functioning of this four liquid stages. Once it is meeting the required, then LHRS is released. The release function also should be verified by ALS, automated launch sequence computer. So that release command is verified, then only it authorizes the solid motor ignition, thereby enabling the liftoff. So that confirmation of the release function, it should not be through some spurious chattering of release function detectors like connectors. So there the triple modular redundant logic is 2 out of 3 has to confirm that release has happened. So that is also we have incorporated. These are all part of some FMECA which has improved the overall reliability of the system. Go ahead with next slide. This is some typical example where we have to stop the redundancy. What I was telling, original design was the right side picture. The cartridge level redundancy was there. Both the skew and main charge were redundant in a mechanism. The left side is what we have finally converged. That is because initially I explained we should have that 120% of charge has to be demonstrated as part of margin demonstration. So if you have a dual cartridge, 240% of the charge has to function without any disintegrity of housing in a mechanism. So designers express some concern that it will become very huge and it will complicate the design. So we actually heard this reliability even though wanted this way, but finally we compromised to some extent. We found the major reliable redundancy is required where the electrical energy in cube is converted to a chemical energy. The chemical energy is further amplified through a main charge and affecting a function. So within between cube and main charge there are no new failure modes. With the electrical energy conversion we can have an electrical failure or a cube failure due to its own charge related failure. There quadruple redundancy is required. Within the main charge, there are no new failure modes. We agreed for this. That system only is flying in GSLV and Mark 3. So this, the reliability engineer should be open enough to hear such a concern and tailor this redundancy to avoid unnecessary complexity. That is the idea of this slide. Go on with next slide, please. This is another way of, you can see the solid motors are ignited, the special purpose motors. Two motors are adjacently located. So you have a safe on device through the explosive transfer, it initiates a initiator called TBA. Left side is very elegant. You see less complexity involving less number of active components. Right side is in line with the single motor, which is the main motors of large vehicles have got this circuit only. But when you incorporate more number of motors like this, it becomes so much complex. It has to be housed in a intrastage where some 4 motors are there. So it will become heavily crowded with a lot of explosive circuits running inside a cramped subassembly. So here we found, even though it gives a marginal improvement, the option to gives a marginal improvement, we agreed for the first configuration, which is only flying in Mark 3 vehicles. So this is also a way to reduce complexity, maybe a small compromise and reliability, but worth doing there. It avoids another component number of explosive lines are reduced that indirectly improves the reliability. So this is another approach. Go ahead, next slide. Okay, design phase, I think the review, audit, all these things one way or other we have already discussed. We can go to next slide, please. Similarly, the output of FMECA, we generate qualification plan. One thing what I thought we will do is most of this FMECA will lead to some insight into the where these items are getting assembled. Once the pyro systems or explosive system function, it can affect whatever I told, the pyro shock, where the adjacent systems are located, whether it is away, stay away. So there is a requirement of pyro shock test of sub-assembly. So at integrated level, we do a system functional testing. And all these adjacent modules as in flight is assembled and its functioning is verified later after subjecting to this shock survivability test. These type of inputs are taken from FMECA and used for deriving a qualification or acceptance testing. So sometimes the debris also is generated. I told bolt is cut. Bolt should not fly away, so it should be contained. So whether such systems like shrouds or some capture features are incorporated in system to prevent any flying debris, all such verification will be done in overall system configurations. It may not be a part of that particular system. It will be part of sub-assembly. That time we will verify based on the FMECA findings. Can you go to next slide, please? So this development test is whatever I told you earlier is qualification. Development is definitely a part of the design and development teams. Freedom is there. They will have a drawing. They are also free to do and evaluate their system limits. They may go slightly beyond the margins also to see its limits. And sometimes it can be done in a subscale level first and full scale level later. All these freedoms are there. Sometimes the cold soak environment will be more appropriate to test the effectiveness and confidence. So sometimes they may subject to environmental test. For example, cryo stage, a lot of pyros are there. It has to be tested at some say liquid hydrogen temperature, like 20 K. So the 20 K, the item has to function, it is a chemical. So whether it will function or not has to be verified. So all such verification will be done as part of development first. Once they have a minimal confidence only, they will offer for photo and qualification phase where quality people, here quality people can be an observers just to see what is happening, what is the limit and all they, it will improve their database, but they need not interfere with their freedom. Next slide, please. In qualification place, it will be based on an approved plan. It will have all the documents. Every scheme of test scheme will be reviewed by committee. Every article going will be certified. Process compliance is ensured for these articles. And monitoring scheme, what are the measurements to confirm the satisfactory function. If it is environmental, it should be based on the environmental test specification by project, whether that specifications are incorporated in the chambers, all these have to be verified during qualification phase. And of course, it is aiming to demonstrate reliability in case of pyros. If it is dual mode or single mode, in that sense, failure mode also will be tested. Go on, next slide. So this qualification, I indirectly told all these documents should be available. All this to be configuration. Configuration control is a process by which all the peers, project representatives and quality assurance and quality control people, fabrication experts, they all authorize the drawing. It means basic standards of drawing, and that is sealed and released through a drawing office. So this, even the documents are controlled like this. So they have to follow such controlled documents. Here there is no freedom for developing agency. They got to adhere to all this. So every items have to be certified, I told. So all tests will be in participation of QA. Next slide, please. This is a process document, whatever I told about configuration control. This is also a process. Here also, if it is a pyro area, all the peers in the area are a member of a process review committee. The developing agency will present the way they want to process the particular item, and it will bring out all the raw materials required, water items. There are some O-rings, there are some sealants, thread sealants, there are some Teflon tapes and chemicals used in the processing. All such items, what is the make, what is its precedence, where they have used, all this will be discussed. The peers also will contribute. Go for this supplier rather than this supplier, all such inputs you will get in the review. Finally, this process document also will be a controlled document, reviewed and released document. And this document also contains the acceptance plan for each system. It gives an assembly and checklist. The QC checklist also a part of document which the observed values will be presented and the compliant certificate will be presented later to future flight readiness and review committees by QC. There is an NDT committee which also reviews the NDT outcomes and with its own acceptance criteria. So NDT also very much important in all this. Certain orientation of particular hardware. There are certain conical boosters. It should be in a specific orientation. If it is put in the other side, major and minor diameter is wrongly oriented, then it can lead to some functional problems. So there are very important deductions have to be there. As I told, there are certain interface gaps within the train that also can be brought out through NDT. So that acceptance criteria will be verified and it will be reviewed and cleared by NDT review committee. Finally, based on successful acceptance test only, this will be cleared for further induction into flight. Go ahead with next slide. In acceptance testing, more or less similar only. So all this, whatever I told in qualification is applicable. Finally, they will give a certification of product and which will be presented in flight readiness. Go next. Here I will come to what I skipped earlier. How to arrive at the reliability value for a device, pyro device. Here you can note down some four factors I have put: criticality, state of the art, verifiability, and complexity. These are all given certain numbers based on experts and reliability engineer. And I will just show in next slide how it is implemented. So you can have the values of for very critical item, the criticality factor will be 3. If it is minor 1, so it will be between 1 and 3. State of the art also, if it is a proven design adopted 1 to 1, it is 1. If it is slightly modified, it is 2. If it is altogether a new design, then it is 3. Similarly, certain aspects can be verified. If it is totally not testable, 1. If it is totally testable, like hydraulic system, whatever, hydraulic launcher hold release system, it can be done. If it is something in between, partly tested and partly not tested, based on judgment, we can arrive at any number between 1 and 10. Complexity is something relative number of parts in a system decides the complexity. If I give some example, liquid systems are complex, cryo systems are most complex, whereas solid motors are less complex. Very simple, highly complex. We can say simple can be a solid motor, complex can be a cryo system. Something in between maybe liquid and other control systems. So these are all judgments with a consulting experts. Reliability engineer gives this rating. Go to the next slide. So I have given some typical example how you can apportion from a launch vehicle, each like a stage 1, stage 2, stage 3, stage 4, and satellite. In satellite, we have satellite and satellite separation system. So in satellite separation, the required reliability based on the apportioned number from launch vehicle or mission is 0.9862. Same approach is applied there also. I am just for simple explanation, I am taking this branch. Reliability apportionment start from mission, comes to launch vehicle, from launch vehicle individual stages, and then satellite. Each stage it has got structure, it has got propulsion, it has got control system, it has got separation system, it has got avionics like that. Each module will have the relative like this. We will put those factors and arrive at a number from the mission to launch vehicle to the particular stage to structure like that. So this is the way apportionment works. When it comes to the main satellite, you can see the number arrived from 0.9862 is 0.990946 is a required number for satellite separation system based on the factors 313. So that numbers are nothing but criticality, state of the art, verifiability, and complexity. So main satellite is a clamp band system which is used right from ASL. We say bolt cutter, everything is something no new thing. It is a proven design. And criticality is definitely system has to function. And similarly, verifiability is not testable. He has put one. So complexity is there. 3, because it is relatively less complex compared to other ball lock and other systems in the same level. When you say all this evaluation, you have to consider the same level. What we are trying to do is, what is the target reliability of overall reliability? We are apportioning to individual subsequent elements. So you have to compare between the options available in the same level. It is not we are trying to compare with liquid stage with this. We are comparing with PPL and nano satellite with the main satellite. What is its complexity? That way only it works. So we have arrived at a number. So we have to arrive at a number for bolt cutter. As I told earlier, based on factor of safety, that 6 lines are there for structure because it will be qualified to that particular factor of safety. So what is the bolt cutter reliability? One bolt cutter, if it is a single point bolt cutter, that number is same as that of first. But we have redundant bolt cutters. Any one functioning is enough. Clamp band has got 2 bolt cutters. Any one bolt cutter cutting the bolt will be sufficient to release. So it is redundant. So redundant means that the R becomes in parallel path. So 1 minus R will become the series. R will be parallel. So failure will be in series, success will be in parallel. So the reliability is drastically reduced. You can just see for 60% confidence level. From 101 test, it comes to 9 tests, which is a doable. Anybody will agree to go with for 9. Maybe so due to some other additional requirements, it can be more than this. But for reliability demonstration of this number, it requires only 9, which is doable. So this way, every element of pyro can be arrived at based on the technical reliability of question. You have to keep in mind it is a top-down method. You start from mission reliability. If mission is something like point 0.9, what should be the launch vehicle reliability? Then what should be the stages reliability? In stages, what are all its elements? What should be its reliability? If it is a stage separation, there you will have one pyro. That pyro, what reliability it has to based on similar assessment you can do. So this is a technique used for by reliability engineer to arrive at the target reliability for a particular pyro device. Go on with the next. So here quickly I will see, I have put some few case studies. Even though I gave a very tough system, you have to be very tough. No freedom is given right from qualification to flight readiness. Just I want to share, in spite of a very tight and rugged system, we went through certain issues, certain lessons. It is always the case. You cannot expect any process will drift. So definitely the noise factors will be there. So you have to be prepared to handle such a situations. But just I will give a glimpse of few lessons which will throw some light on what type of things we have done subsequent to the issues. Can you go to first issue? Next slide, please. This is a deck plate. Most of the avionic packages are housed in interstages using a honeycomb sandwich deck plates. It is honeycomb core. The right side gives a glimpse of that. Top and bottoms are face sheets. It is sandwiched between two sheets is a honeycomb core. So these honeycomb decks are invariably used for various interstages to mount all those modules, avionic packages. So these elements have to be bonded and cured in a oven, and finally it has to meet certain requirements. That requirements are nothing but lap shear and flash face tension specifications are there. But these deck plates cannot be tested. So some coupons are there which will represent these decks. So it has to meet this specification. If it is okay, when we do such a test, we should ensure that A cohesive failure, that is the core only should come out. It should fail the honeycomb. It should not be a peel off from the surface. It means that the capability is not come out in the test. So adhesive failure cannot be used. But a cohesive failure is there, it can be a proper test. If that test is showing a lower value, there is some problem in processing. So you can just imagine. We got very low value, something like 10, 11, like that, instead of 45 in a 10 side test. Go to next slide. This deck plates were in demand for that time, nearing launch. Some 2-3 L deck has to be assembled, and it has to meet the vibration test goal, putting all the packages on the interest. So that time the light test coupon shown very low value. Light test means it will be tested in our center. Some initial tests are done by work center. The values were okay, decks were supplied. The light test coupon which came along with the coupon has shown this inadequacy. We found that surface preparation is not good. I am just given an idea, bottom tick and into. So it should have a crisscross pattern to aid this adhesive bonding. So that is not evidenced in the coupons. So we found that this preparation has led to very low value. But a question remains whether a deck is acceptable. Coupons are not bad, acceptable. But what to do with the deck? So we have found a deck which is realized during the same period using the same adhesive batch, same oven conditions. So we have extracted coupons from the deck and found that those deck plate capabilities are okay. Then we cleared the deck which are supposed to be supplied after this test. Go to the next slide. Anyway, it is not a good idea. It gives some element of uncertainty. How well this sample deck would have represented the actual deck is a question which is valid. So later we found, we were insisting this earlier also, these coupons are not a real representative of the deck. So the deck itself should have an extra area to extract a coupon right from the deck after completing of all the processes. So later all the drawings were amended, extra area is provided on the deck to extract a coupon after successful processing. If those deck coupons are okay, then only those decks will be supplied to us. So this is implemented. It looks now very elementary. Should have been run right. This all these lessons are like that. You find finally this should have been done in the first place. Why you went through a sample and got into problem? Natural question. Next slide, please. This is another case. What I have not told is the first stage separation is by an explosive cut, which cuts the stage. So, yeah, 7 mm interstage is cut by an explosive cut to affect the separation. You can just see a 7 mm thick forged ring is cut by an explosive cut. So that is the capability of the explosive cut. How that explosive cut is accepted is a 4.4 meter long processed cut. So it should meet some charge density conditions, which will be done at the ends, and some sample cards are tested. That every end of the cards are also will go through a test called flat plate test. That only I am showing this. So in to our surprise, in one of the batch testing, we found so every card will go through a 20% higher thickness margin test. As I already told, we will not take chances. So 7 mm thick means 8.4 mm thick plate has to be cut from the same flight batch of cards. Then only those cards will be sent for flight integration. So that test has failed in one of the tests earlier. But it is a flying card with so much heritage. We were wondering it has passed as a successful nominal test. So how it has failed in a margin test when we looked at, we found that the plate which is extracted for a flat plate test, it was against the FLSE is oriented across the grain flow of the plate. Actually, the actual system and the FLSE functioning is in the same way. FLSE functioning and the grain structure is the same. But in the flat plate, they are free to extract either side. They have done across to extract a sample plate for test. So this was a costly lesson. Later we have found this is enforced before the plate is submitted for testing. We should ensure the grain flow pattern is in the expected lines. So this is something which has happened at random. All the time they were following this. They never cut across, but that particular time they cut and it has failed. So it has given some more insight into in tightening the test article clearance. Good. Next slide. Okay, this is something you can, a shear bolt which is of maraging steel, it has failed. We can go to next slide. I will slightly rush up because we are nearing 7:20. So this is nothing but a cause is due to a condition called stress corrosion cracking. So these three conditions are required. Material should be susceptible to the SEC, and it should be closer to a corrosive environment, and there should be a pre-stress in the element. So all three are applicable. We are in either Trivandrum or in Sriharikota. It's a coastal environment, so corrosive environments is maraging steel is highly prone. But people tend to use this maraging steel only because of its attraction of strength, but it is wrong idea to put in a bolt like this because the bolts are normally subjected to a preload, which causes the third element called pre-stress, the stress. So all three, what happens is this will not fail at instantly. Over time, it will come out. That is a risk in SCC. As installed, everything will appear fine. But without any further load, when it is stored also, it will fail. That is what happened here also. The stage is kept on a bay. Suddenly, somebody found it has failed on board. So later, corrective actions are next slide. We have gone for a safer material, something very close to that. So we should have some protective coating if possible to prevent the corrosion getting into this. And residual stress, in some cases, we can minimize by heat treatment. But always it is better to go for safer material. Now, based on all this, there is another material committee has come, DRT materials. They screen all these materials for end use so that all these conditions of pre-stress and conditions of storage, everything is verified. Then only a material as a choice is cleared by the committee, is introduced. Next slide, please. Something similar. A job bolt is nothing but a equivalent of a rivet, but it can take care of both the tensile stress as well as the um, shear stress. Rivet can handle only the shear loads. Here it can take both the shear loads as well as tensile load. That is a attraction of job bolts. Some job bolts which are just like rivet, it will not rotate. But when they submitted for in our PSLV integration, we found certain bolts are rotated, that is loose. So that is a issue. Can go to next slide. So these job bolts are a proprietary item. It's a supplied by a procured item. They give the kind of tools and the installation procedures, what the break-off length, what is a hole size, what is the length to be used, all are specified. Next slide. So here the individual, we found some simulation. What it has happened is more number of members are forming this joint. So when you do some in a joint, you will have some 300, 400 volts in a ring to a stiffened member. So that many job bolts are there. In a given joint itself, there will be easily 15, 16 volts, job bolts. But first of all, installation, they will check it is okay. Like that, if you go, finally, when you finish the entire ring and the completion of the stiffener joint, the first job bolt can get loose because it will resettle, and then the first job bolt would have developed some gaps through which the loosening is happened. So it is a good idea to first is adherence to the supplier's procedures, Second, verification you have to do only at the end, not after immediate installation. Next slide. That is the lessons I have put. You can go to the next. Similarly, there is some two conditions of aluminum alloy is there. One is for a skin, another is for stiffener. So this T4 and T6, somewhere work center we found it got interchanged, which is not good because one is require higher strength. So naturally we cannot use a lower strength material there. So we found how to verify that it has not happened. This anyway, we got to rework. But what happened to the suppliers earlier, which is waiting for future flights? So those things were verified for something called electrical conductivity. You can note this IACS is a international annealed copper standard. This is conductivity of aluminum is compared against conductivity of copper. That way only it is defined. So there is a specification. It was found lower. So it is always possible to verify any finished order. So these checks are done for ruling out such a mix-up is not there, which is already cleared and accepted. It is a lesson we have found in this. So we introduced additional check of conductivity measurement. You can take it. Next slide. Similarly, height difference because of some improvement in jig height measurement of a core brace rod, which is the lowermost interstage, which supports a solid motor, 3 mm difference on it. So the 3 mm difference is not acceptable considering its overall height of say 2.5 meters. 3 to 4 mm, that much is sensitive because it is involving certain interfaces which will be mounted external to this. We looked back, can you go to the next slide? So this jig changes has caused this. To prevent certain shim usage, somebody has incorporated the shim feature into the jig itself. But the assembly people who are using this assembly jig, they customarily put the shim also. So it is already a built-in shim as well as a externally put shim, which has caused this error. But it was not directed at the work center because the laser tracker inspection probe had a diameter which is equivalent to this difference of 3 mm. So probe offset was not included in the measurement. So it gave an expected value. So nobody suspected and cleared this. When we measured at our Vikram Sarabhai Space Center, we directed this, due to which three major hardwares were sidelined used for PSW with core alone configuration, which doesn't require these interfaces. So very costly. So core alone missions were there, which has come handy to use this CBS. But this type of changes are very, very critical. We cannot do any change in established procedures. Can you go to the next slide? Here one, you can go to the last slide. I am just touching up. Last means 3 slides later. Now what happens is previous one. Previous. Here, no, next to next. Next slide. Here you can see there was a case you might all know the PSLV C39 where payload fairing did not separate. It is also involving same whatever I explained earlier, the extra length of transfer lines we have put. Here what happened due to some specific thermal environment, the heat shield has slightly expanded. So the station point of vertical separation system moved away from the initiation point. You can see a horizontal line in the sketch, the model. The horizontal line and the vertical line should be almost aligned condition, which moved away by say 4.5 to 5 mm. So even though the initiation happened, the system did not pick up. So it failed. So go to the next slide. So this is the radial initiation mode, which is not a preferred in explosive train circuits. Radial initiation is the least preferred mode of initiation, but it is flying like this for so many years. So we never looked back on this The C39 failure has opened this fallacy in this design. So we switched over to an axial initiation mode, which involved some modification in the systems. Finally, this axial mode, whatever I told, 5 mm, 4.5 mm expansion has caused a movement of vertical system from the initiation point. Here it can jump as high as 10 mm. As a margin demonstration, they have even demonstrated 20 mm during the qualification, pre-qualification phase. It is a very robust. So we should be able to withstand such a noise factor. There is a thermal environment which has caused some expansion, but our system was very sensitive to that environment. So this noise factor and there was lack of robust in our system. Can you go to next? So in such a cases, when we come to system reliability, the organization should be very supportive and it should give free hand. And we felt this always, even after failure, no individuals are targeted. They give a freedom. Even some individuals come out with certain anomaly detected, they will be welcome and they see that corrective actions are incorporated, even though it causes certain difficulties of undo, redo type of task. They are appreciated. Sometimes openly the chairman is appreciated for bringing up certain specific anomalies which was not detected. So such open system and non-blaming culture is required. So we should promote this in aerospace system. Even some passenger flights and all, we should welcome such a feedback. Viewer, even the users, even passengers can give some ideas to this. That is what prevailing there. So we should be able to open. Next slide. Open minded. Similarly, the working people should be aware when they do some flight integration, they should concentrate fully on their job, doing right at the first time. I told you, every launch vehicle is new only for us. For reliability purpose, based on number of successful flight, we will give some number. But actual things are progressing as if it is new to us. Small errors can lead to very complex. So 4 mm error just now in the previous slide, I told. It has caused a one mission, which was very heartburning to all of us. But always ISRO comes back, bounce back with properly addressing what is the limit of the system. Those decisions are made by concerned experts. No management thrusts their idea into this. The team who is capable of taking the best decision only entrusted with taking such a decision. That is also a good sign of an organization, high reliability organization. These are all certain cultures we should follow. Next slide. So this is my last slide. Thank you for your patient hearing. So zero defect program also says that everything we do with full concentration and do it right at first time and every time. So this should be motto in not only in aerospace, whatever job, even an assignment questions when we prepare. I think some FMECA, FTA examples can be used in real life products. You can see user manuals of certain electronic devices. They give an attachment in the manual, troubleshooting on your one. That is nothing but based on this FTA, they try to the consumer itself capable of finding out what went wrong before embarking on the service centers. These are all something we can adopt from aerospace to even everyday life. And we should concentrate and do. We should not lack our concentration when we do our work. That is a motto of zero defect, which can be used in every industry. Thank you for your patient listening. Thanks for the organizers for giving this opportunity. Few more acknowledgement I have to make. This presentation is made with the help of certain friends, Dr. Murugesan, who is retired from VSSC, Mohan Ananthanarayanan, who is a stalwart in quality control area, he is also retired, and Sunoj and Maruti, who are still serving in mechanical system area, they have contributed to this. Maruti is a reliability expert. He is working on some more new methodology of with the minimum data how to arrive at reliability. He is working on this. All these people are helped in making this presentation. I thank
Madam,
them
good
so
evening,
much.
ma'am.
Thank you.
Ma'am.
From participant side, any questions?
Hello. Hello, sir. Is it
Yes,
audible?
sir, tell me.
Can you throw light on pyro igniter, sir? Pyro igniter. Some information about. Hello.
Yes, please.
Sir, regarding a pyro igniter, how it is used in solid rocket motors?
This igniter, you mean?
Yes, sir. Pyro.
Solid igniter motors are two items are there. One is pyrotechnic, which is comprising of pyrotechnic powders, which is used for retro type of small motors, which has to give high thrust in a very short time, like 1 second. Whereas solid motor igniting motors are like nothing but a miniature motor. It will be ignited through a safe form pyro circuit, what I have shown schematically, a manifold to improve the number of success paths in an item. It receives two input and one output. So one of the device failing in safe form, still it will be able to transfer the stimulus. The initiator is called through bulkhead initiator. There is a bulkhead separating a donor and acceptor. So donor receives the inputs from this pyro chain. Through a bulkhead, a shock wave transmission happens at the other end of the bulkhead, which is acceptor. The acceptor in turn deflagrates and initiates a pyrotechnic charge, which initiates a pellets in an igniter, which converts this into a burn rate based solid propellant in an igniter, which gives a burn rate and ignition of solid water. That burns for a sufficient time, something like 100, 200 milliseconds. By the time the ignition of motor happens. So it is relatively slow igniting. Pyrotechnic, the whole process has to be completed in 1 second. Pyrotechnic igniter has got another initiator, which is an electrical initiator, which can be directly powered. Skip is there. There is a main charge which initiates the pyrotechnic charge, something like BO1, boron potassium nitrate. Such a powders are used, and that powder gives the output and initiates the igniters, and the igniter in turn initiates a motor. That is also something like STPP, but it will catch fast and ignite. It will give a relatively higher thrust for 1 second or 1.5 seconds duration of burning.
What type of igniter is used in ISRO, sir? In this, you have told us two type of igniter.
What
What
type
type
of
of igniter? Pyrotechnic or pyro ignite? Which type of igniter is widely used in ASRO mostly?
all are only one type of igniter, solid propulsion. These motors are by same type of igniter, whether it's 200 or first stage. It is a pyrogen igniter only. Pyrogen is nothing but a burn rate based, a miniature motor type igniter. What I was telling is auxiliary motors, which is coming to picture only during separation systems functioning. There, these pyrotechnic igniters are used. Pyrotechnic igniters are never used in main motor ignition. That igniters are called pyrogen igniter, which I explained, which is initiated through a set of initiator pyro circuit elements, say from manifold, TBI type of chain.
Yes, thank you,
Pyrogen
sir.
igniters are designed as something like solid motor.
Thank you.
Okay.
Okay. I feel deeply honored to extend my heartfelt gratitude to our distinguished resource person, scientist Sri Ramachandran. Sir, especially your and insightful session gave brief idea about launch vehicle, uniqueness in space, and various case studies, etc. Thank you so much, sir, for your enlightening session.
Thank you. Thanks once
Next, I
again
would
for
like
the
to
organizers. Very much devoted to them because I retired some 1 year back. It has given an opportunity to relook into whatever we have done in the launch vehicle. It is really a blessing. This gave an opportunity to revisit whatever we have done. So thanks a lot. All the
Okay,
best to
thank you
all
so
the
much.
participants. If you have still some doubts, you can reach out through my mail, which will be with the organizers. Feel free. We can always come back. No problem. Thanks a lot.
Thank you so much, sir. Next out, I'd like to thank all the participants. Thank you all for your active participation. Thank you.
Thank you.
Now, I would like to hand over the next session to Mrs. Priyanka, Assistant Professor, Department of Triple Macet. Over to you, ma'am.
Good evening, everyone. On behalf of Martandam College of Engineering and Technology, a warm welcome to the resource person, coordinators, and all the participants to this Atal Faculty Development Program on emerging trends in space and computing technologies. It is my great pleasure to welcome and introduce our esteemed resource person for today's second session, Dr. D. Senita. She is an experienced academic and researcher with more than 10 years in the experience of 10 years in the field of computer science and engineering. She is currently working as a senior scale assistant professor at Manipal Institute of Technology from 2010. Before that, she worked in various esteemed institutions like BITS Pilani Goa campus and at Marthandam College of Engineering and Technology, Tamil Nadu. She has a strong background in teaching and research, especially in the areas like computer science, machine learning, and deep learning. She obtained her PhD in computer science and engineering from Manipal University in 2024. She also holds a master's degree in computer science and engineering from Anna University and a bachelor's degree in the same field from Manonmanian Sundarnar University. She has published over 20 research articles in various international conferences and journals. She has authored numerous IEEE, Scopus Index, and peer-reviewed journal articles focusing on heart disease prediction, machine learning, and deep learning. Her recent works include optimization techniques in medical data analytics and AI-driven healthcare applications. Once again, I extend a warm welcome to all of you for this enriching learning experience. Now, I would like to hand over the session to our esteemed resource person, Dr. D. Senita. Over to you, ma'am.
Yeah. Thank you, Priyanka, madam, for my introduction.
Thank you, ma'am.
Can you able to see my screen?
Yes, ma'am. Yes, it is clear.
Yeah. First of all, I would like to express my gratitude to Marthandam College of Engineering to giving me this opportunity. So next, I would like to express my sincere gratitude to Dr. Martin, the coordinator of this Atal FDP, for giving me this wonderful opportunities. Also, I would like to extend my appreciation to all faculty members and coordinators who have worked hard to make this FDP a success. Also, a special thank to my dear JC Prabha madam, who have been my inspiration. I have a special connection with this institution because I began my career at this prestigious college. So when I began my career, so JC Prabha madam guided me in all aspects, providing invaluable support and encouragement. I'm grateful that our friendship, which started then and continue to this day, dear madam. Thank you so much, madam. So I'm Senita, faculty from Manipal Institute of Technology, Manipal. Today, I'm going to present heart disease prediction using machine learning techniques. So the special motivation of this particular research, nowadays, the death rate of heart disease is high because it will not allow the patient to recover and finally may lead to death on spot. So according to the survey conducted by the World Health Organization, 17.9 million people die each year from cardiovascular disease, accounting for an estimated 31% of all deaths worldwide under the age group of 70. More than 75% of CVD, the cardiovascular disease deaths, occur in low-income and middle-income countries. 80% of all CVD deaths are caused by heart attack and stroke. So the need for this, why heart disease prediction is required? So the first reason behind this, it's high mortality rate. So cardiovascular disease are the leading cause of death globally. As I told in the World Health Organization statistics, there are 17.9 million deaths occur annually due to cardiovascular disease. That is 31% of all deaths in worldwide. When we see the real world scenario, there is a person, a 55 years old man who no prior symptoms suddenly suffers a fatal heart attack. So here the heart disease often remains undetected until it's too late. So it is very essential. So the second reason why it is early detection serves lives. So many heart diseases do not show early symptoms. So the prediction enables preventive measures and timely treatment. So there is a world scenario. When we take an example, a 42-year-old woman undergoes a routine checkup and is found to have high cholesterol. So there is a symptom. So they can find the this one symptom immediately. So timely intervention helps her prevent a heart attack. So the third reason, reducing healthcare cost. So late stage treatment, when the heart any disease last stage, the treatment is expensive and it is resource intensive. So early prediction allow for cost effective disease management. So when we take the real world scenario, a 60-year-old diabetic patient follows a preventive care plan after being flagged at risk for heart disease. So this avoids costly surgeries like bypass operations. So the fourth reason, high risk population like our India, in developing countries like India. So there are 75% of cardiovascular disease deaths occur in low income and low and middle income countries like India. Early identification can help implement preventive healthcare strategies. When we take a real world scenario, in rural India, a lack of healthcare accesses leads to late detection of heart disease, resulting in high mortality rates. So now we have AI-based remote screening helps it identify the high-risk individuals. So the next need is advance in AI and machine learning. So now AI-driven predictive models improve risk assessment accuracy. Also, it helps doctors make informed decisions and personalized treatment plans. So in real time, hospitals use AI-based model to analyze ECG and detect early signs of heart disease. It allowing doctors to intervene before a critical event occurs. So the last need is the lifestyle and preventive measures. So early warnings encourage a healthy lifestyle. Also, it helps manage diet, exercise, and stress to prevent heart disease. When we see the real world scenario, 35-year-old office worker uses a smartwatch to monitor his heart rate. So the technology improves, the device alerts him irregularities, prompting a doctor visit that prevents future accomplishments. So now we'll see the statistics of heart disease in India. We know that it is very much essential for the saving lives, reducing treatment cost, and enabling early intervention using advanced AI and medical advancements. So the statistics of heart disease in India, here heart disease particularly, there are different types of heart disease are there, cardiovascular disease, and another one name is ischemic heart disease. This is also one of the type of heart disease. This is the leading cause of mortality in India. So in the year 2015, cardiovascular diseases were responsible for over 2.1 million deaths in the country, accounting for more than a quarter of all deaths. Among individuals, the age 30 to very early age, like 30 to 69 years, there were approximately 1.3 million cardiovascular deaths, with 68.4% attributed to ischemic heart disease and 28.0% to stroke. Also, the age standardized CV cardiovascular disease death rate in India is 272 per 1 lakh population, which is higher than the global average of 235 per 1 lakh. In urban countries like Mumbai, heart attack have become a significant health concern. In the year 2022, heart attack accounted for 10% of all deaths in the city, and this percentage increased to 11% in 2023. So the number of heart attack deaths was 10,683 in 2021, 9,470 in 2022, and 10,077 in 2023. So day by day, it is increasing fastly. So these statistics underscore the critical need. There is a need for the effective prevention, early detection, and management strategies to address the growing burden of heart disease in India. So to predict that heart disease, to save the lives, we are going to use the machine learning technique. So we'll see what is machine learning and how the machine learning helps to early prediction of heart disease. So the machine learning is a field of artificial intelligence that enable computers to learn from data and make decisions based on that data. So this is just like a human learn from past experiences. Machines can also learn to improve their performance on tasks without being explicitly programmed for each specific task. So now look at this object recognition. So here we see example for the object recognition. Here this is the human. So a human can learn from past experience and make decision of its own. For example, here there is an object. So the object is car. So here the human already when he saw the car or bike, human can easily identify them because the ability comes from previous experiences and observations, because day by day, day to day, these things are like normal. So the human can easily identify. So the based on the observation, the human can tell this is car or bike or whatever the image that is coming from the previous experience and the observation. So the goal here is to illustrate that machines can also learn to recognize objects similarly. So now here you can see the object is given. So it is what is this object? So that is asked from the person. So we just imagine that that object is not car. So that means we just represent a person who has not been exposed to certain things like a car. Maybe the person knows something, but what he doesn't know that. So other thing, it is like that is why it is given question mark. It is bubble indicating lack of knowledge. So that means he's seeing first time, not possible. Later he can identify because the previous observation was not there. So once he observed, once he know the previous experience, then immediately he can tell the animal or whatever it may be. So he can observe and learn based on the previous experience. Also here we can see So here that there are some objects. So those objects are already the person knows. So now these objects already the person know the information as well as the previous experience is there. Now when we ask the human question is now based on the past experience, because the person know that all those things. So when we ask the person what is this object, the person can tell this is car. So also already all these things have already it is told to the person. So now how about the machine? So here the machine learning concept, here the machines need to be trained. See how the human, the previous experience or observation, whatever it may be. So here we need to we need to train the machine with the data and algorithm to learn. So all those things we need to train the machine learning. That machines can follow only for the instruction. Based on the instruction it will perform. Based on the instruction it can take the decision of its own. So here this section, so this one will emphasize that while machines currently follow strict instructions, like we can take as a calculator, they can also be trained to learn from examples. So the idea is to show that by exposing a machine to various examples so that it can learn to identify the objects on its own. Also here we can see the example like addition, subtraction, some computation. So these tasks are straightforward because they rely on precise instructions. So emphasize that machines do not possess understanding like humans. So here we want a machine to act like a human. So to identify this object, first it has to identify the object, also predict the price in the future. Also it has to do the language like correct grammar, language like understanding, also recognize the faces. So to learn, machines need to data called a training data set, we usually call, just like a human, learn from the experiences. Also, machines improve their capabilities by analyzing large amount of data. The more relevant data they receive, the better they can perform. So what do we do? Just like what we did to human, we need to provide experience to the machine. So here, when we see here, the first picture shows the machine. Then we have some images. So this we usually call it as a data set. So this is what we called as data or data set, or we can say training the data set. We need to train these data set to the machine. So we first need to provide training data set to the machine. After provide the training data set, the next step is then devise algorithms and execute programs on the data with respect to the underlying target task. So then using the programs, identify the required rules. There are some set of rules are there. We need to identify those things. So the next step is to extract the required patterns. It learns to recognize the important features in the data. Features means in the sense the attributes. Those things we will discuss later. So also we need to identify the relations between that data set, maybe the attributes as well as the class values, so that the machine can derive the inferences from the data. So here, so the first thing is we need to provide the data. So the start with the data set. So the trained data set we need to provide. Then devise algorithms. So it creates an algorithm that can analyze the data. So there are multiple algorithms are there in the machine learning. So we are going to analyze the data by using the algorithms. The next thing is we are going to identify all the rules. So the machine identifies patterns or rules from the data. So the next step is to extract the patterns. It learns to recognize the important features in the data. What are all the features for that particular data set? So finally, we'll derive the inferences. The machine can make predictions or decision based on its learning. We as a human being solve various types of problems in our day-to-day life. Various decisions need to be taken. Depending on the nature of the problem, machine learning tasks can be broadly divided in. So there are three types of like machine learning. One is supervised learning, unsupervised learning, and reinforcement learning. So most of the time we will use the supervised learning and unsupervised learning. Also today my presentation mainly focused on supervised learning only. So basically supervised learning means we have the label data set. Label data set in the sense, for example, I have a heart disease data set. I have some attributes in the sense like I have the blood test or maybe BP result, something like that. So these are all the attributes. I have some 13 attributes are there. Also, I have one label also because I'm not going to test now. First, I'm going to train. So when I wanted to train, what I will do, I will just go to the hospital and I will collect the existing data set. In my presentation, I'm going to show you the UC heart disease data set. Already second benchmark data set is available. So I'm going to use that benchmark data set. So that data set, there are 13 attributes and one class value. So in the class value, there are, it is a binary label, binary classification. So there it will be 1 and 0. So 1 in the sense, that patient is having a heart disease. 0 means there is no heart disease. So that means supervised learning means we know the class value in advance. Okay, so based on that, we are going to train our model. Then we are going to test with the new data. So here, so supervised learning means we have the label data set, then meaning each input has a corresponding output. So the machine learns to map inputs to the output. So also, when we see that unsupervised learning, it is opposite. That is unsupervised learning. There is no labels. Here we have labels, but in the case of unsupervised learning, there is no labels. The machine tries to find patterns or groups. Maybe okay, these are all the for example, the number 1 to 10. Okay, if it is coming 1 to 10, okay, it will make a group. So nearest neighbor or something like that. So machine tries to pattern or grouping in the data on its own. So the here we have that clustering concept also. So here you can see this example. In the image, left side samples are there. Samples are all the data. I can say the data set. So I have the data set of cars and bikes. So I have also label. Label is nothing but here I am just telling whether it is a car or bike. That is the symbol, this thing. So now I'm going to train the data. So I'm just training something like that. So these are all the features are there. For example, 4 tires and we have the glass or some attributes. So if these are all the attributes, features are there, then we are training the machine. This is car. So like that bike, some different features. So based on that, we are training our model. So after training the data set, I have already trained this. Now you can see F of this box is nothing but the data set. Okay, so the data set, what data set contains are all these samples are there. So now I'm just giving some testing data set. So I have given the label data set because so I'm expecting to produce some output value. So actually the same similar color, all those things are not there, but the features are almost same. So what it will predict? Definitely it will predict as a car. So the next, I wanted to classify this. So if the possible output values of the functions are predefined and discrete or categorically, it is called as a classification. So now it will classify as a car. So then now predefined class means it will produce output only from the labels defined in the data set. For example, even if we have trained car and bike. Out of these things, it will check because we have trained. So it will just check whether this particular features, which one is matching. So definitely it will match with the car only. So if it is matching with the car, then we can say, yeah, almost it is correct. Bike means because we can't accept that. So maybe the accuracy level will be less. So now you can see the classifier. Here, I have given the training data set. So in the training data set, one is type. So now this trained data set. So I'm just two categories. One is elephant image and another one is tiger image. So now I wanted to represent so this machine learning, this classifier represent a machine learning model that has been trained using this data set. So that means this classifier takes an input image and predict the category based on the learned pattern. So already we have learned. So now this question is, it is here it is, we are like this identify the animal. So we are giving another one image. So this left side, it is like our trained data set. Now I wanted to test that whether my model works perfectly or not. I wanted to check whether it is identifying this as an animal or not. So this demonstrates how the trained model applies its knowledge to classify new unseen images. So if it is predicting this as a elephant, that means I can say, I can say, yeah, this is the best classifier, as well as I'm getting my model is the training, whatever we did, that is perfect. So one more thing is there, that regression. So the regression also regression also it's unsupervised learning only. Here, if the possible output values of the functions are continuous real values, then it is called a regression, because we cannot predict this is the value. So it may vary. For example, house rent or new house, we cannot say that the value may be the same. So it is not the this one perfect value. So here you can say that if of the data set and the house we are giving, we are getting some values. So the classification and the regression problems are supervised, because the decision depends on the characteristics of the ground truth labels or values present in the data set, which we defined as experience. So now here we can see the data set. Now what is unsupervised learning? So as I told you, unsupervised learning, we won't that class value is not there. So only the data set is there. The class value is not there. We do not need to know the labels or ground truth values. Now I'm just doing the cluster thing. Grouping similar data points together. That means similar data point, or that means similar kind of attributes or similar kind of values. So here I can just cluster two things. One is car, that is one cluster, and bike as another one cluster. So here also one more this thing is there, association rule. Association rule, like we have finding the relationship between data items, like we know that, like market basket analysis. So here when you see car is associated with the air freshener. Also another one example is given, that is bike is associated with the helmet. So here the items are frequently used or purchased together. So that way this association rule mining works. So this is again the one more example for the unsupervised learning. So here there are some data points are there. So when we are we don't have the class value, so we are just clustering it based on the features or based on the threshold values. Okay. So next important thing is data pre-processing. So data pre-processing is very, very important because it is a crucial step in machine learning that involves transforming raw data into formats suitable for modeling. The proper pre-processing technique will improve the quality of the data, also can significantly impact the performance of machine learning algorithms. So there are like different steps in pre-processing. So the one of the first step is data collection. So that means we need to gather data from various sources. It depends on our application. Suppose if we are working with the school database or student database, or maybe we are working with hospital database. So it depends on that. We need to collect the database from data set from different databases. Also, the collection of database is important because it ensures that we have enough data to train and test our models effectively. So that is the first thing in the pre-processing. Second step is data cleaning. So we need to clean the data. So because in the data, so in the data set, because so in some data set, some missing values will be there, or in some data set, some duplicate values will be there. So all those things will not give the proper accuracy. So we need to clean the data by using some methods. So the first one is handling missing values. That means we need to remove the missing values and fill the missing values. For example, in some places, this what they will do is, if there is a missing value, that entire record only will be removed. So such places and all automatically our accuracy and our training, all those things will be affected. Also, some places it will be given mean value. Wherever the missing value comes, that particular data will be substituted by the missing value, or median, or applying zeros, ones, or ignoring the entire row, and so on. So many missing value techniques are there. Because if we why we have to handle the missing values, because missing data can lead to biased models or errors in the analysis when we analyze. So the next thing is, we need to remove all the duplicates from our data set. We need to identify first and remove duplicate entries in the data set by mistake, or so many reasons for the duplication. So why we have to duplicate? Because the duplicate data can skew the results and lead to overfitting. So to avoid that, we need to, when we get first collect the data set, after collecting the data set, first thing we need to clean the data set, then only we can go for the next pre-processing technique. So next thing is feature engineering. So in feature engineering, there are two things. One is creating new features, feature selection. So what exactly the feature creating new feature is? Combine existing features. Already in the dataset we have features, or extract new features from raw data. So sometimes, like when we train and test, we feel if this particular attribute, if we include, it may give better results. So we can include that new feature. Also, why we have to do? Because new features can provide additional insights and improve model performance. Then next one is feature selection. So this is important, very, very important technique, because this method use the techniques like correlation analysis, recursive features elimination, or tree-based methods to select important features. Because in some example, if you see maybe original, it will be 50 attributes will be there, or maybe 100 will be there, but all those things are not required. So when we are doing feature selection, so it will reduce the number of features. So then features can decrease the model complexity and improve the interpretability. So feature selection and creating new features are important aspects. So also the next thing is splitting the data set. So the splitting the data set is like we need to split the data set, divide the data set into two sets. One is training data set into training as well as validation. So validation is very, very important because we want to check whether our model is correct or not. So then after that, also it ensures that the model can be validated and tested on unseen data, which help prevent overfitting. So finally, the data pre-processing is important for machine learning. Also, it properly processed data leads to better model performance. It reduces the risk of overfitting and ensures that the model generalizes well to new unseen data. Also, each pre-processing step should be carefully considered based on the specific characteristics of the data set and the requirements of the chosen algorithms. Yeah, now the missing data, it is basically unavoidable issue because in real world, when we take the real world data sets, any data set it can be, it's a common to encounter missing values due to various reasons. For example, human error. Maybe when we are surveying some data sets, sometimes it may be incomplete. So sometimes it will be technical issues, maybe sensor failure when we are collecting that, maybe because of that we are not getting the proper, or maybe non-responsible in surveys. So in all the surveys, people will not provide the proper information. There also we are missing. Also data corruption during collection. So like that, various reasons are there. So imputation is very, very important process because we have to replace all the missing values. So it is the process of filling the missing values in a data set with suitable values. Also, this can be achieved through various methods such as like statistical techniques, like we can use substitute mean value or median value or mode. Also, for predictive modeling, we can do the regression or KNN model, KNN, K nearest neighbor model, or we can do the advanced methods. Now, we have multiple imputation technique. So the goal of this particular imputation, maintain the data set integrity and usability. Also, it allowing for the future analysis and modeling without significant loss of information. Also, the problems caused by this missing value is this missing value. Suppose if you are not if you are not substituting the proper values, it will end up with the error. Also, that is classification error. So machine learning algorithm, we have that like many algorithms. One of the algorithm is artificial neural network, support vector machine. These processes require complete data to function correctly. Otherwise, that incomplete data, such machine learning algorithms will not give the correct answer. So we need to handle all those things. Also, we have loss of information. If rows with missing values are removed, suppose in case if we remove that entire row, so that means that, for example, suppose if I have very less number of record, out of that, if I am removing one record because of the missing value, it lead with the bias. Also, we need to specify the algorithms and missing values. Here, that artificial neural network complete input vectors for each training example. Here, the missing value in input features can disturb the training process. So we need to handle all the missing values in the data. So there are different types of missing data are there. So the first one is missing completely at random. Second one is missing at random. Third one is missing not at random. So the first thing is missing completely at random. So that means, for example, when we are taking a survey, a respondent accidentally skips a question due to a maybe printing error. So this missingness is, we call it as a random. So when the data is missing completely at random, the analysis remains unbiased. So, and the remaining data can be considered a representative sample of the entire data. Then the second type of missing data is missing at random. So, for example, if older individuals are less likely to respond to a same survey question about their income. So that is very, very important attribute. So the missingness is related to age and observed variable. Then the implication, that means the substitution, allow for more sophisticated imputation methods because the missingness can be accounted for using the available data. Then there are different types of different two types of imputation is there. One is single imputation method and another one is multiple imputation method. So simple imputation method is nothing but single imputation to estimate a single value for in the data set, single value for each missing value, or to estimate a set of values for each missing value for the multiple. Okay. So for example, I'll consider this is my data set. This is the UCA hard disease data set. It is available. There are three in the data set. Total 303 records are available. Also, here it is a binary classification we are considering, particularly the predicting the presence or absence of heart disease in patients. So here you can see there are attributes. Total, there are 13 attributes like age, sex, and chest pain, and resting blood sugar, cholesterol, then fasting blood sugar, resting ECG. So then maximum heart rate achieved, then exercise induced angina, then old peak, like that. So here you can see I have total 13 plus 1. This num I am considering as a class value, or we are telling this is the class label. Okay, so class label in the sense, this is the this is supervised learning. So in supervised learning we know the class value. Okay, so here the data set is not image. Here this particular UC heart disease data set, also this is available in the Kaggle heart disease data set also. This example is for the UC, this one, Kaggle heart disease or UC, both this thing, 303 records. But recently in the year 2029, this is very old data set. In the recent year 2019, I think, yeah, they have in the Kaggle heart disease data set only 20,000 records are available. So in that also some papers are available right now. But if you see that maximum papers are used this particular data set only. So here all the description is there. The domain value is nothing but we usually call it as the threshold value. For example, the age is in the year. The age is considered from the year 29 to 77. Then the sex, then the chest pain, all those things, these values only will be represented. It will not be written any text or anything. The numerical values only will be given. So the each, here you can see, this is the data set. Easily, we can freely download the data set. I have just taken some sample. In this, you can see 13 attributes, age, sex, then cholesterol, and so on. That final, you can see it is written class. So class, if you see, it is a binary classification, 0 and 1. So wherever 0 is there, that means this particular record, each has a record. So this 0 means, for example, first person we can take, first record. So the person here is 63 and then all the informations are there, related information. At the end, it is given 0. So class value 0 means this particular person don't have the heart disease. For example, the second one, the class value is given 1. Okay, so that means this particular person has a heart disease. Okay, so based on that, we will train, because we know the class value. We are training our model. Then for when the new patient come, we will just test with this particular trained data set. Yeah, so this is one of the multiple ischemic heart disease multiple imputation technique. Yeah, how that multiple heart disease. Another one thing, single imputation and multiple imputation. When we compare with single imputation and multiple imputation technique, single imputation technique end up with the bias value we will not get. When we compare with the multiple imputation technique, we won't get the proper accuracy or anything. The one reason is because here single imputation technique, same value. For example, if it is a mean, I'm calculating mean, and wherever the missing value comes, I'm just applying that same value. So, but here in the multiple imputation is not like that. We are just, every time we are generating new values for each missing value, multiple values we are finding, and we are just applying, we are substituting in the model. So here, the first first step is it is like UCA data set with the missing attributes. That means in the UCA data set, if you just download and see the data set, there are missing value in the original data set. But in some places in the data set, it is uploaded. They have considered some mean or median they have added, and they have uploaded in the form of without missing values. But whenever we are training or whenever we are training the model, better we have to take our original source, okay, with missing values only. So in the data set, there are missing values. So that is given to that missing original data set having the missing values. That information is given to that data set is given to the data clustering with respect to specific attributes. So we know that what exactly the cluster does. So here the data set is divided into groups, clusters based on certain attributes, certain characteristics. Maybe the range, for example, if the cholesterol range, it is from this range to this range. So based on that, different clusters that we will just decide how many clusters we need to give. So that this cluster patients based on the age, attributes, gender, or certain health metrics. So this helps to organize the data into more manageable and similar group. So after clustering this particular data set, so next we are going for finding the nearest neighbor for each cluster with respect to specific attributes. So here that each group created the previous step. That means I'm going to identify the nearest neighbor for each data point. So the nearest neighbor is a similar subject based on the attributes or considering. So this is important for filling in missing values, as similar subjects can provide useful information. After finding the nearest neighbor, the next step is to calculate the membership function. So here the membership function, this step involves determining how closely related each data point is to its neighbors. The membership function helps in understanding how much influences each neighbor should have when estimating the missing values. So after calculating based on this membership function, we are replacing the missing value. Okay, after replacing the missing value, now we wanted to validate whether our we got some missing value. Now I wanted to validate that whether it is proper or not, within the range or not. So for that we need to validate. So here we can do in two ways. But according to the procedure, we have to use some machine learning. But suppose if you want to check whether your code is working perfectly, so what we can do is we can just self-validation also we can do. Anyway, we are not going to get any output, but just we can just check whether it is substituting properly or not. So that I will show you for the upcoming slide. So for that, for validation purpose, I have used the random forest algorithm. So many algorithms are there. So I prefer this random forest algorithm because it is a powerful machine learning technique used for both classification and regression tasks. Also, it operates by creating a collection of decision trees and combining their outputs to improve accuracy and reduce the risk of overfitting. Also, how the random forest work is, the first step is the random forest is an ensemble method, meaning that it combines the prediction from multiple models. For in this case, we have different decision trees. So to produce a more best result. Also, for example, how this will work. I have a data set. We saw that data set, the previous data set. Suppose, consider I have like 1,000 patients with attributes. Such as maybe some attributes are 13 plus 1 class values. So we know that that class value, yes or no. Yes means the patient has the heart disease. No means there is no heart disease. So now here we wanted to test the random using the random forest model. So first randomly select the subset of the data set to create multiple training sets. For example, I'm creating 100 different subsets of 100 different subsets of 700 patients. Okay, so each from the total original record, that is the 1,000 patients. So now what I'm going to do is I'm going to building a tree for each subset, build a decision tree, different decision tree now. During the decision building process, at each node, randomly select the subset of features. For example, age, cholesterol, blood pressure, or whatever it may be, to determine the best split. So that result in the forest of 100 trees. So each trained on different data and features. So now I wanted to make the prediction. So how it will predict when a new patient data, for example, there is the patient age is 55, cholesterol content is 240 range, blood pressure some 130. Just assume that. So now what it will do, it will each of the 100 decision trees will make a prediction. 100 trees will, that is why that random forest is selected. So it will predict it and it will tell either the patient is having 0 or 1. So patient is having heart disease or not. Suppose 60 trees predict 1, indicating that heart disease, and 40 trees predict 0. So it will take the maximum. So the random forest model will output 1 because the maximum that 60 trees, decision trees predict as a 1. So the final prediction, since it has the majority vote. So based on the voting, this random forest will decide whether that particular patient is having heart disease or not. So now the model, how it will evaluate is after training the model can be evaluated using, there are metrics we have as accuracy, precision, recall, F1 score on the data set. So the advantage of the random forest is it handles noise and outlier well, making it less prone to overfitting compared to single decision tree. So now, after this this one performance evaluation, the same thing in the form of this one. Like this is the algorithm for that ischemic heart disease multiple imputation technique. So here the first input what we are giving is data set with missing attributes. Then the output we are giving, we are expecting the output is data set with imputed values. So first we are starting with the process. Then we are starting with the iteration. So for each instance y in the data set x, the loop here the loop continues only for instances that contains the missing value. So wherever, that means it will start from the first attribute. For example, my first attribute is maybe cholesterol. So it will start from the patient one, that attribute 1 to till the end. So like that, it will check, is there any missing value is there in that particular attribute. So like that, it will check attribute 1 to nth attribute. So after that, we are getting the nearest neighbor. For each instance, retrieve the k nearest neighbors. This step identifies the most similar instance in the data set based on certain criteria. Also, when we see A of this one, A of y, yeah, E is missing A of y. Here we are just checking, is the for each that attribute A set of attribute. That means the subset, we can say subset. In A, how many are there? A1, A2, small a1, we can use instance y. Specifically, it is focuses on those attributes that are missing. So then next I'm initializing two variables like J1 and J2. These will be used to calculate the imputed value for the missing attributes. Then for each Z belongs to N, this loop through each neighbor, nearest neighbor, that's the Z. In the set of, already we have set of this one missing values, neighbors, N found in that particular step 3. Then we are calculating here lower approximation membership function. So M is nothing but the membership function. Formula is lower approximation plus upper approximation divided by 2. So we are calculating that. After calculating that, we are just calculating the J1 and J2. So this after calculating this J1 and J2, we are just checking. I'm going a little bit fast because I want to discuss with the results and all. So here the J1 by ending the product of the midpoint, that is the M, and the value of the attribute from the neighbor is set. So this accumulates the weighted contributes of the neighbor value. Then I'm just adding J1 with M. So this will update the J2 by adding the current value of J1. What exactly is stored in the current value and the midpoint M. So this step aggregates the contributions to help normalize the imputed value. So here the loop, that iteration, the loop will end for the neighbors. Then I'm just checking the condition J2 less than 0. So that means if it is greater than 0, J2 greater than 0 means it is used to terminate how to handle the imputation. So that is why that A of y. So A is nothing but the attribute. So if J2 is greater than 0, if it is greater than 0, then set the missing attribute A of y of instance y to the ratio of J1 and J2. So this represents the weighted average of the neighbor's value. Suppose else if J less than 0, that means J2 that means it will produce the next step. That is nothing but it will set the missing attributes A of y. Already we have that A of y to the average of all the values of attributes if A from the neighbors is set. Also it divided by N, that is the number of neighbors. This provides a imputing the missing values. Okay, now we'll see that some of the results. So this particular table, accuracy of various single imputation techniques. So as we see, there are two types of imputation technique. One is single imputation technique and another one is multiple imputation technique. So in the single imputation technique, there are few imputation techniques are there. F-fill. F-fill means forward fill. For example, in the data set, I have a missing value. So what it will do is, what is the next value? That next record, the next value. So that value will be substituted in this particular method. Then B-fill. B-fill means backward fill. The backward value, numerical value will be filled wherever the missing values. So then mean will be calculated and it will be substituted in that wherever Also the thing is mean. Mean will not be calculated each and everything. Once it will be calculated, and that same mean value will be given all the, suppose if there is a 1 lakh data set, in there 100 missing values are there. That means it will substitute everywhere, all 100 places, the same single mean value will be substituted. So when we are substituting like that, definitely we'll end up with the biased this thing. So that is the thing. Then KNN imputed, that is K nearest neighbor, that nearest value will be imputed. So these are all the example for the single imputation method. So when you see the accuracy rate of this single imputation method, basically that KNN imputation method is giving better accuracy. It is 80. Okay, now we will see the accuracy of various methods with and without the use of single imputation. So here you can see here the same example, same single imputation, all for imputation, and this is the without using imputation method. That means without using single imputation method means I have not used any imputation technique. Rather using any single imputation technique, either I would have ignored. That means ignore means I would have given ignore means that particular record only will be removed, or maybe all the values are filled with random number. Say example, I'm just filling 0 for all 100 missing values, or maybe 1. So something like that. So without using imputation method, so we are getting 0.76. We are imputation technique and without using imputation method. So there is a significant difference is there. This is for single. Now we will see, suppose if we are using multiple imputation technique. So then what will happen? Okay. Yeah. Now this example, this is my data set. Okay. So you see how this is data set. So in this data set, you can see there is a missing value here, missing value here, then missing value here. This is original data set. Missing value here. Yeah, like that. Some missing values are there in that particular data set. Now we'll see how multiple imputation works. Okay, this is imputed value. I'll show you with the data set. Okay. Now parallelly, you can see left side is my data set. Okay. So this is after applied that ischemic heart disease multiple imputation technique. So here in this example, so this is the resultant one. So the age when you yeah, here you can see that third row, here that second column, here also third row, second column, this one. So that is exactly yeah, this is 1 2 3 4 chest pain and resting blood sugar. So this is for resting blood sugar. So in the resting yeah, this one is resting blood sugar. Now we will see what is resting blood sugar range. The range is the value is between 94 to 200. This is the normal one. Okay, so 94 to 200. This is the threshold value. Now we will see between 94 to 200. So here I have a missing value. So that means after substituting that multiple imputation technique, here I got the value 134.505. So that is between that particular the threshold value only. That means this is correct. This is not the final result. This is like self-validation. So we can just check whether what I have applied my model, whether it is giving properly or not. We can just check with the in the Python, this facility is there. We can just open and see whether what I have what I got in that particular. So like that, I have kept some sample also. Here you can see This what I did is just I removed, these are all the first thing. These are all the different records. Okay. So record number 11, 79, this is not the age, different record number, because in that record number 1 to 303 records are there. So randomly chosen. Then this is the attributes. In these attributes, for example, the first record number 11, attribute name is cholesterol. So here the threshold value is between 126 to 254. So now the original value which was there in this particular record, there is no missing value. But to verify whether that my model is working or not, to verify that, I just removed and I just verified that whether it is working or not. After applying my substitution technique, it is giving 168. That means it is between 126 to 254. So that imputed values, this original value 168. After applying my model, I got 239. That is between this particular range, multiple imputation technique. So similarly, checked with multiple things. So here you can see wherever it is nil. Nil is nothing but in the original data set only, there is no missing value. So these values I just, for the self-validation, I removed and I just verified. So everywhere when we are applying the multiple imputation technique, there is no bias also getting the proper output. So similarly, some more records, the record number, attributes, and all we are getting within the attributes only. So this is the imputed data set. Basically, all those things, it is compressed and I put, so imputed data set, 303 records and 14 columns. This is after substituting my multiple imputation technique. Then this is the predicted class. So the predicted class is nothing but the label. So here the label is 11 means it is there is a heart disease. 0 means there is no heart disease. Final predicted class. So this is a comparison of ischemic heart disease multiple imputation technique with other imputation technique. So in first we saw that what is the significant difference when we are using with imputation technique, without imputation technique, with the single imputation technique, without imputation technique. There is a significant difference. So now when we are comparing with the multiple imputation technique, here compared with the different multiple imputation technique, like fuzzy rough set, this is also one of the multiple imputation technique. Fuzzy C means imputation, expectation maximization imputation, and this is the proposed ischemic heart disease multiple imputation technique using random forest algorithm. So when we see in terms of accuracy, sensitivity, specificity, precision, F measure, the proposed the proposed technique is giving 92.8% accuracy, and sensitivity is 96, and so on. So comparatively, this multiple, the proposed method is giving better accuracy. So this is the confusion matrix which I received. So in the confusion matrix, here the actual label and the class, and this is the predicted label. So this here there are 4 things. One is true positive and false positive, false negative, and false positive and false negative. So a true positive in the sense the number of instances correctly classified as positive. Then true negative in the sense the number of instances correctly classified as negative. Then the false positive is the number of instances incorrectly classified as a positive. And the false negative is the number of instances incorrectly classified as a negative. So the conclusion, the single imputation based missing data handling methods are easy to implement, but may provide biased imputations. But in the case of multiple imputation based methods, you generate a set of possible values for each missing values. Also, in this work, in any heart disease, maybe it is ischemic heart disease or CVD, whatever it may be, the techniques was verified using the benchmark UC heart disease data set. Also, we can try with the Kaggle heart disease with 20,000 records. That also we can try. Also, each instances in the neighborhood is compared to its similar class values. So why it is mentioned similar class value means anyway we are checking the nearest neighbor, but we are checking whether that see there is an missing value is there. First, I'll check whether that missing value, that particular record, belongs to the class value is 0 or 1. Suppose if the class value is 0, then so if it is 0, then I will take only the nearest neighbor of 0. I will not consider the nearest neighbor of 1. So that also gives better result. So we can just compare with the similar class value. So we can ignore that the other class values. So that also gives better accuracy. Then applying that this particular ischemic heart disease multiple imputation technique, random forest classifier gives better performance when we compare with the fuzzy Repset, fuzzy Siemens, and expectation maximization. Okay, so actually I will stop here because the next topic I have selected as a future selection technique. So it is not possible to complete. So I will just stop here. Yeah, that's all, madam.
Thank you, ma'am. Participants, any questions? Okay, thank you. So as we come to end of today's informative session, I would like to express my sincere gratitude to all those who contributed to making this session a great success. First and foremost, a sincere thanks to our esteemed resource person, Dr. D. Senita, for delivering such an engaging and informative session. Your deep insights into heart disease prediction using machine learning techniques have truly enlightened us, and we appreciate the time and effort you took to share your knowledge with us. Next, I would like to extend my gratitude to all the participants for your active engagement. We look forward to seeing you in the upcoming sessions and hope to continue this journey of learning and growth together. Thank you and have a wonderful evening.
Thanks. Thank you. Thank you for giving me this opportunity once again.
Thank you, ma'am.